Hi, so I'm going to talk about the principles of MRI imaging and steps and also the basic physics behind the image acquisition. But first, let's have the history behind the discovery of MRI. So yeah, MRI it was discovered simultaneously by two physicists in 1947, which is Felix Bloch and Edward Mills Purcell. So MRI machine it was invented by Paul C. Lauterbur in September 1971, and the first clinical images were obtained in 1977 by Paul Lauterbur and Peter Mansfield. So, magnetic resonance imaging, or MRI for short, it is one of the most fascinating diagnostic procedures known to medicine. So, the images produced by the big tube can be breathtaking, and it provides crucial information on the many diseases. So MRI it uses a magnetic fields and radio frequencies rather than ionizing radiation, which is used in X-rays and CT. MRI is also known as NMR, which stands for nuclear magnetic resonance. So the magnetic field strength in MRI machine it is measured in Tesla. The majority of MRI systems in clinical practice uses 1.5 or 3 Tesla, referred to as 1.5 or 3T. So these produces an extremely strong magnetic field. So the basic MRI MRI components or hardware are the magnet, radio frequency or RF coils, gradients, computer system, and console, and the patient handling system. So, this is the picture of an MRI machine, MRI scanner. These are the parts of the MRI scanner. So, as you can see here, so this one is the magnet, this one. So the gradient coils here, radio frequency coil, as you can see, the patient is inside. This is the patient table. This one here, this one is the scanner. So the magnet has a large magnetic field that is homogeneous over a large area, and it is the component that aligns the protons in the body. So the RF coils or radio frequency coils, this one transmits and receives the RF energy into from the body. So RF coils, these are located within the magnet, as you can see earlier, and it is relatively close to the patient's body. So MRI uses RF signals to transmit image from the patient's body, and the RF energy used is a form of non-ionizing radiation. So the RF pulses that are applied to the patient's body are absorbed by the tissue, and it is then converted into heat. So a small amount of the energy is emitted by the body as a signal used para mag-produce siya og image. So gradients, this induces a linear change in the magnetic field. It is also for spatial encoding. A gradient is just a change in the field strength from one point to another in the patient's body. So our bodies, as we all know, are made up of 70 to 80% of water, which is composed of hydrogen and oxygen atoms, which is H2O. So MRI, it relies on magnetic properties, and magnetic properties of hydrogen atoms to produce images. So a small parts of the hydrogen atoms acts as a tiny magnets, and this one they are very sensitive to the magnetic field. So the hydrogen nucleus is composed of a single proton with no neutrons, as a spinning charged particle, and this produces a magnetic field of called magnetic moment. So normally, this hydrogen proton spins on a randomly oriented axis, so there is no overall magnetic field. So there's 5 simple steps in MRI image acquisition. So first is that the patient is placed in a magnet. Second, the radio wave is sent in. Third, radio wave is turned off. Fourth, the patient emits a signal. And the fifth, the last the step, the emitted signal from the patient is used for reconstruction of the image. But now I'm going to explain more detail about the image acquisition for MRI. So yeah, normally the water molecules inside ours are arranged randomly, as I stated earlier. But when we lie inside the magnetic field, our water molecules move at the same rhythm or frequency as the magnetic field. So, in a magnetic field produced by the MRI atoms, atoms lines up either north or south, and about half of the atoms go each way, but there are few unmatched atoms. So ones that don't move along the magnetic field are called low energy water molecules. So this one. So to create an image of the body part, for example, the brain, so the machine focuses on the low energy water molecules. So by sending radio waves that match or resonate with the magnetic field, or when a radio frequency pulse is applied, the unmatched atoms spin the other way, so it flips. So the low energy water molecules then absorbs the energy they need to move along the magnetic field. And yeah, when the machine stops, it stops emitting radio waves, or when the radio frequency is turned off, the water molecules that had just move along the magnetic field release the energy they had absorbed. So katong na-absorb nila nga energy, ila ra pong i-release balik and go back to their position. Yes. So this movement is detected by the MRI machine, and the RF signals. A signal is then sent to the computer, which uses an imaging software para i-translate ang information into an image of the body. So the computer uses a mathematical formula to convert the signal into an image. So that is the steps and basic physics behind the image acquisition for MRI. Thank you.